Hello judges, my name is Daniel Park and I'm an inventor in the Genspiration prize competition, and I'm very excited to share with you today about my invention. But first, what is the issue that my invention aims to address? Well, I aim to address the issue of perchlorate pollution in the environment. Perchlorates are a group of environmental pollutants that make their way into our groundwater and into our soil, into our agriculture, from sources such as industrial runoff. But not only that, they're also found in toxic concentrations in Martian soil, which obviously pose a great challenge for us were we to try and colonize Mars in the future. From there, they go on to enter our bodies and then eventually harm our thyroid glands. Now, I'm a Floridian, and here in Florida, we have lots of gorgeous environments and ecosystems, such as the Everglades. An unfortunate trend, however, in recent years has been the fact that pollution has been increasing in these areas, and I really want to address this issue. I noticed that when we focus on stopping pollution, we often focus on pollutants such as oil or lead, and it's great that we're focusing on these, but we often find ourselves overlooking certain pollutants, such as perchlorates, that can be just as harmful. In fact, in recent years, a study found that in a sample of over 3,000 residences, over 83% of them had perchlorate concentrations in their water supply that were well above the detectable threshold. Now, current methods of getting rid of perchlorates are things such as industrial processes or specialized lab equipment, which is obviously not very sustainable nor practical for the everyday consumer. And my invention aims to address that. My invention is a novel method of bioremediation that is naturally breaking down these perchlorates in the environment through proteins produced by the bacterial PCR-ABCD genes. So how did I do this? Well, the first thing I did was construct, to my knowledge, the first ever complete model of the PCR-ABCD protein complex so I could analyze its interactions and effectiveness. Then I ran some simulations to test how well this perchlorate reductase, the protein that is coded for by these genes, would bind to the perchlorate molecule in the environment to break it down. Turns out they would bind really well, and they were predicted to be very effective at breaking them down in the environment. Furthermore, I actually was able to identify the specific genetic sequences coding for these proteins and optimize them to be better expressed in a much more commonly accessible bacteria, for example, E. coli. Now, what does this look like on the market? Well, I envisioned a future where we could have these different engineered E. coli in things such as pellets or powders or solutions. You could just sprinkle them into the environment affected by perchlorate pollution and naturally get rid of them. It would be much more sustainable and much more easy to use. The bacteria would just naturally proliferate in the environment, clean up the entire area, and we would be done. Now, with this method of bioremediation, I've developed a much more sustainable, effective, and practical and easy to use method for the everyday consumer to rid their environment and rid their homes of this toxic perchlorate pollution that is plaguing our environment in the current day. Thank you, judges.